exposure causes a variety of health effects, such as kidney damage, cardiovascular damage, and cognitive effects. The ways in which people are commonly exposed to lead are through occupational and environmental settings, such as piping in the water line, eating out of pottery, window manufacturing, and living in old homes with lead-based paint. With a severe water crisis in Flint, and the knowledge that many homes are at lead concentrations at 10 parts per billion, we have determined to focus our project on the effects of cognitive function in children and adolescents at a blood lead level of 10 part per billion and below. Cognitive effects, such as low test scores, have been observed at levels as low as 3 parts per billion. Interventions may be the best way to solve this lead issue. It is our goal to test these two filters, a faucet attachment and a pure 7-cup water pitcher, to determine at what concentration it is acceptable for filter use.
For our testing, we spiked College Station water with lead to get 3 different concentrations at a level of high, medium, and low. We then ran each concentrations through the pure water pitcher and measured the resulting lead levels using a mass spec. For usability, 67% strongly agreed the pitcher was easy to assemble, and 50% agreed the faucet attachment was easy to assemble, while 50% somewhat agreed. Finally, 67% strongly agreed that they would purchase the pitcher over the faucet attachment.
With efficiency testing, the average time it took the faucet attachment to filter 500 milliliters of water was approximately 8.45 seconds, whereas the pitcher takes 504 seconds, equating to approximately 8.4 minutes. The results regarding the contaminated water itself include the following. Our control, which was College Station tap water, yielded 0.57 parts per billion as a final concentration and amounted to a 50.9% reduction. Our high lead level sample yielded 5.12 parts per billion as the final concentration and a 95.3% reduction. Essentially, the higher the concentration of lead, the more lead ended up being filtered out. Our findings did not correlate with manufacturer claims of a 97.9% reduction rate when filtering lead-contaminated water at a pH of 8.5.
After completion of our study, a few design recommendations have been determined that will assist in usability and lead filtration. Our first recommendation is to have a better secured lid that does not stay in place when pouring the water. Next, the tray should be labeled front and back, as it was frequently inserted backwards. An aesthetic design that would benefit the customers is to have the amount of water labeled on the side so it is evident how much water is being consumed throughout the day. For the faucet filter, we suggest an easier, cohesive way to insert the filter on every faucet. Finally, we would like to see more efficient lead removal at concentrations of 1 part per billion, and caution those who market the product about their word usage of claiming that the filter removes 99.9% of lead when in fact it does not.